Hello there, and welcome back to another episode on Why Should I Care About SDFs. Today's topic is going to be CSG, which stands for Constructed Solid Geometry. And if you try to do this kind of thing with polygons, you will know it's kind of a hard problem because not only you need to compute all these different intersections, but you will need to add or remove vertices, even re-triangulate the entire thing, and it gets pretty messy real quick. But with SDFs, as we saw in the previous video, it's really easy to do these kind of operations. Like for a union between two shapes, the only thing you need to do is for every point, you just get the minimal distance between all of the distances to all of the shapes on your scene. Because as we know, the moment you are inside a shape, the distance to that shape is going to be negative, and the moment you are outside of a shape, the distance is going to be positive. So if for every point you get the minimal between the two, you are going to get the guarantee that as long as you are inside either this shape or either this shape, the minimal distance is going to be negative, and it's going to be considered to be inside of the combined shape. So in order to do an intersection between the two shapes instead of a union, what you do, instead of getting the minimum between the two distances, you get the maximum between the two. And why is that? Because for an intersection, what you want, you don't care if a point is inside one shape but not on the other. You only care about the points that are inside both of these shapes. So basically the points like this one that has the distance to both of their shape are negative, because the moment you are outside, like for example this point is inside this shape but is outside this one, the maximum distance is going to guarantee that all of the points that are not inside both of the shapes are going to have a positive distance, and only the ones that are inside both of the shapes are going to get a negative distance and be considered to be inside of the combined shape. And in order to understand the next operation, first you need to know what happens when you invert an SDF, when you flip the sign on it. And basically this is what happens, that now the distance, since it's flipped, the more inside you are on a shape, the more positive the distance is going to get, and the more outside of the shape you are, the more negative the distance is going to be. So it's basically, instead of representing the distance to the shape, it represents the distance to the inverted space of the shape. So knowing this, if you want to subtract two different shapes, what you do is basically an intersection between the shape, the distance to that shape, and the inverted distance to the other shape. So basically what this means is you are doing an intersection between this shape and whatever is outside this other shape. So at the end, as you can see, since this one is inverted, the more inside you go of this shape, the more positive the distance get, and the more negative goes, the more inside this other shape you are. And you get the guarantee by taking the maximum distance between the two, that only the points that are actually inside this shape but actually outside of the other shape are considered to be inside of the combined shape. So basically it subtracts this shape from this other shape. And you say, okay, computer, that's a lot, but that's cool, I guess, but what can I do with this? And I'm glad you asked, and I could get a little sample for you. Let's start with a basic circle shape, and then add two little circles with a subtract operation, and then let's animate both their position and radii over time with a sine wave. And then let's add another subtraction, but this time with a circle deformed on the vertical space, which I will show you how to do this on a future video. But for now, let's just animate this deformation over time with a sine wave, but to a power of 4, so we get this spiky behavior. And then we're going to bring back our old friend, the polynomial smooth minimum, to blend two more circles to our base shape. And just to make it pop a little bit, I'm going to add a little bit of spherical lining to our drawing. And finally, I'm going to add a new weapon on our arsenal that I will teach you on the next video, that is called displacement. And look at that. How cool is that? Anyway, I hope that you find this interesting, and I'll see you on the next video. And as always, stay strong, much love, and peace out.